An IETF language tag is an abbreviated language code defined by the Internet Engineering Task Force in the BCP 47 document series, which is currently composed of normative RFC 5646 and RFC 4647, along with the normative content of the IANA language subtag registry. Components of language tags are drawn from ISO 639, ISO 15924, ISO 3166-1, and UNM 49. These language tags are used in a number of modern computing standards, including those from the IETF related to the Internet protocols such as HTTP, those from the World Wide Web Consortium such as HTML, XML and PNG, and those from other private standardization bodies such as SGML or Unicode, or from national or regional standard bodies like ANSI or ECMA. History: IETF language tags were first defined in RFC 1766, published in March 1995. The tags used ISO 639 two-letter language codes and ISO 3166 two-letter country codes, and allowed registration of whole tags that included variant or script subtags of 3 to 8 letters. In January 2001 this was updated by RFC 3066, which added the use of ISO 639-2 three-letter codes, permitted subtags with digits, and adopted the concept of language ranges from HTTP/1.1 to help with matching of language tags. The next revision of the specification came in September 2006 with the publication of RFC 4646 and RFC 4647. RFC 4646 introduced a more structured format for language tags, added the use of ISO 15924 four-letter script codes and UNM 49 three-digit geographical region codes, and replaced the old registry of tags with a new registry of subtags. The small number of previously defined tags that did not conform to the new structure were grandfathered in order to maintain compatibility with RFC 3066. The current version of the specification, RFC 5646, was published in September 2009. The main purpose of this revision was to incorporate three-letter codes from ISO 639-3 and 639-5 into the language subtag registry, in order to increase the interoperability between ISO 639 and BCP 47. Syntax of language tags: each language tag is composed of one or more subtags separated by hyphens. Each subtag is composed of basic Latin letters or digits only. With the exceptions of private use language tags beginning with an X prefix and grandfathered language tags, subtags occur in the following order: a single primary language subtag based on a two-letter language code from ISO 639-1 or a three-letter code from ISO 639-2, ISO 639-3 or ISO 639-5, or registered through the BCP 47 process and composed of 5 to 8 letters. Up to 3 optional extended language subtags composed of 3 letters each, separated by hyphens. An optional script subtag, based on a 4-letter script code from ISO 15924. An optional region subtag based on a 2-letter country code from ISO 3166-1 Alpha 2, or a 3-digit code from UNM 49 for geographical regions. Optional variant subtags, separated by hyphens, each composed of 5 to 8 letters, or of 4 characters starting with a digit. Optional extension subtags, separated by hyphens, each composed of a single character, with the exception of the letter X, and a hyphen followed by one or more subtags of 2 to 8 characters each, separated by hyphens. An optional private use subtag, composed of the letter X and a hyphen followed by subtags of 1 to 8 characters each, separated by hyphens. Subtags are not case-sensitive, but the specification recommends using the same cases in the language subtag registry, where region subtags are uppercase, script subtags are title case, and all other subtags are lowercase. This capitalization follows the recommendations of the underlying ISO standards. Optional script and region subtags are preferred to be omitted when they add no distinguishing information to a language tag. For example, IS is preferred over IS LATN, as Spanish is fully expected to be written in the Latin script. JA is preferred over JA JP, as Japanese as used in Japan does not differ markedly from Japanese as used elsewhere. Not all linguistic regions can be represented with a valid region subtag. The Su-national regional dialects of a primary language are registered as variant subtags. For example, the Valencia variant subtag for the Valencian dialect of Catalan is registered in the language subtag registry with the prefix cerca as this dialect is spoken almost exclusively in Spain. The region subtag ES can normally be omitted. IETF language tags have been used as locale identifiers in many applications. It may be necessary for these applications to establish their own strategy for defining, encoding and matching locales if the strategy described in RFC 4647 is not adequate. The use, interpretation and matching of IETF language tags is currently defined in RFC 5646 and RFC 4647. The language subtag registry lists all currently valid public subtags. Private use subtags are not included in the registry as they are implementation dependent and subject to private agreements between third parties using them. These private agreements are out of scope of BCP 47. Relation to other standards, although some types of subtags are derived from ISO or UN core standards, they do not follow these standards absolutely, as this could lead to the meaning of language tags changing over time. In particular, a subtag derived from a code assigned by ISO 639, ISO 15924, ISO 3166, or UNM 49 remains a valid subtag even if the code is withdrawn from the corresponding core standard. If the standard later assigns a new meaning to the withdrawn code, the corresponding subtag will still retain its old meaning. This stability was introduced in RFC 4646. ISO 639-3 and ISO 639-1 equals, RFC 4646 defined the concept of an extended language subtag, although no such subtags were registered at that time. RFC 5645 and RFC 5646 added primary language subtags corresponding to ISO 639-3 codes for all languages that did not already exist in the registry. In addition, codes for languages encompassed by certain macro-languages were registered as extended language subtags. Sign languages were also registered as XLangs, with the prefix SGN. These languages may be represented either with the subtag for the encompassed language alone or with a language XLang combination. The first option is preferred for most purposes. The second option is called XLang form, and is new in RFC 5646. Whole tags that were registered prior to RFC 4646 and are now classified as grandfathered, or redundant are deprecated in favor of the corresponding ISO 639-3 Euro-based language subtag, if one exists. To list a few examples, Nan is preferred over ZH Minnan for Minnan Chinese. Hack is preferred over iHack and ZH Hacker for Hacker Chinese. And ACE is preferred over SGN US for American Sign Language. ISO 639-5 and ISO 639-2 equals, ISO 639-5 defines language collections with Alpha 3 codes in a different way than they were initially encoded in ISO 639-2. Specifically, the language collections are now all defined in ISO 639-5 as inclusive, rather than some of them being defined exclusively. This means that language collections have a broader scope than before, in some cases where they could encompass languages that were already encoded separately within ISO 639-2. For example, the ISO 639-2 code AFAR was previously associated with the name Afroasiatic, excluding languages such as Arabic that already had their own code. In ISO 639-5, this collection is named Afroasiatic languages, and includes all such languages. ISO 639-2 changed the exclusive names in 2009 to match the inclusive ISO 639-5 names. To avoid breaking implementations that may still depend on the older definition of these collections, ISO 639-5 defines a grouping type attribute for all collections that were already encoded in ISO 639-2. BCP 47 defines a scope property to identify subtags for language collections. However, it does not define any given collection as inclusive or exclusive, and does not use the ISO 639-5 grouping type attribute, although the description fields in the language subtag registry for these subtags match the ISO 639-5 names. As a consequence, BCP 47 language tags that include a primary language subtag for a collection may be ambiguous as to whether the collection is intended to be inclusive or exclusive. ISO 639-5 does not define precisely which languages are members of these collections. Only the hierarchical classification of collections is defined, using the inclusive definition of these collections. Because of this, RFC 5646 does not recommend the use of subtags for language collections for most applications, although they're still preferred over subtags whose meaning is even less specific, such as multiple languages, and undetermined. In contrast, the classification of individual languages within their macrolanguage is standardized, in both ISO 639-3 and the language subtag registry. ISO 15924, ISO IEC 10646 and Unicode script subtags were first added to the language subtag registry when RFC 4646 was published, from the list of codes defined in ISO 15924. They are encoded in the language tag after primary and extended language subtags, but before other types of subtag, including region and variant subtags. Some primary language subtags are defined with a property named suppress script, which indicates the cases where a single script can usually be assumed by default for the language, even if it can be written with another script. When this is the case, it is preferable to omit the script subtag, to improve the likelihood of successful matching. A different script subtag can still be appended to make the distinction when necessary. For example, Ye is preferred over YHEBR in most contexts, because the Hebrew script subtag is assumed for the Yiddish language. As another example, ZH-HANS SG may be considered equivalent to ZH-HANS, because the region code is probably not significant. The written form of Chinese used in Singapore uses the same simplified Chinese characters as in other countries where Chinese is written. However, the script subtag is maintained because it is significant. Note that ISO 15924 includes some codes for script variants that are unified within Unicode and ISO IEC 10646. These script variants are most often encoded for bibliographic purposes, but are not always significant from a linguistic point of view. They may occasionally be useful in language tags to expose orthographic or semantic differences, with different analysis of letters, diacritics, and digraphs trigraphs as default grapheme clusters, or differences in letter casing rules. ISO 3166-1 and UNM 49 Two-letter region subtags are based on codes assigned, or exceptionally reserved, in ISO 3166-1. If the ISO 3166 maintenance agency were to reassign a code that had previously been assigned to a different country, the existing BCP 47 subtag corresponding to that code would retain its meaning, and a new region subtag based on UNM 49 would be registered for the new country. UNM 49 is also the source for numeric region subtags for geographical regions, such as 005 for South America. Region subtags are used to specify the variety of a language as used in a particular region. They are appropriate when the variety is regional in nature, and can be captured adequately by identifying the countries involved, as when distinguishing British English from American English. When the difference is one of script or script variety, as for simplified versus traditional Chinese characters, it should be expressed with a script subtag instead of a region subtag. In this example, ZH-HANS and ZH-HAN should be used instead of ZHCN and ZHHK. When a distinct language subtag exists for a language that could be considered a regional variety, it is often preferable to use the more specific subtag instead of a language region combination. For example, RDZ may be better expressed as ARQ for Algerian spoken Arabic. Extension subtags allow additional information to be attached to a language tag that does not necessarily serve to identify a language. One use for extensions is to encode locale information, such as calendar and currency. Extension subtags are composed of multiple hyphen-separated character strings, starting with a single character, called a singleton. Each extension is described in its own IETF-RFC, which identifies a registration authority to manage the data for that extension. IANA is responsible for allocating singletons. 2 extensions have been assigned as of January 2014. Extension T equals. Extension T allows a language tag to include information on how the tag data was transliterated, transcribed, or otherwise transformed. For example, the tag NTJP could be used for content in English that was translated from the original Japanese. Additional substrings could indicate that the translation was done mechanically, or in accordance with a published standard. Extension T is described in RFC 6497, published in February 2012. The registration authority is the Unicode Consortium. Extension U equals. Extension U allows a wide variety of locale attributes found in the common locale data repository to be embedded in language tags. These attributes include calendar and time zone data, collation order, currency, number system, and keyboard identification. Tags containing AU extension are more likely to be used to identify locale data sets than for purely linguistic content. Some examples include, RUNULATN represents Arabic language content using basic Latin digits instead of Arabic script digits. EILUKAR Hebrew TZ Jerusalem represents Hebrew as spoken in Israel, using the traditional Hebrew calendar, and in the Asia Jerusalem time zone is identified in the TZ database. Extension U is described in RFC 6067, published in December 2010. The registration authority is the Unicode Consortium. See also, Codes for Constructed Languages, Internationalization and Localization. References. External links, BCP47 language tags a current specification, also referencing the related information RFC 5645. Which complements the previous information RFC 4645, as well other individual registration forms published separately by others for each language added or modified in the registry between these BCP 47 revisions. Language subtag registry maintained by IANA, language tags in HTML and XML from the W3C, http, www.langtag.net/ Language Subtag Registry Search an unofficial tool for users to find subtags and view entries in the registry.